Hello students, myself Mutturaju LP, working as assistant professor in the Department of Mechanical Engineering, Vidyavardhaka College of Engineering, Mysuru. And today I will explain dry saturated steam with single stage turbine. That I will explain. Let us see how it will works and all the basics. This one vapor power cycle that I will explain. The concept of before the this one dry saturated vapor power cycle, you want to know the that concept of drainage fraction. The drainage fraction, you know, that it will be designated by the value x, designated by the value x, and then the drainage fraction of mass of steam in given volume divided by total volume. It is the ratio of mass of steam in given volume to the total volume of the steam present, and that will be, let me designated the mass of the steam in given volume with the mg, and the mass of the water that is in the liquid phase, and the mass of the steam. This is the total mass of the steam, and this will be like this formula: x is equal to mg divided by mw plus mg. Let me explain the concept. Consider a volume of a vessel consists of some amount of the volume. In that I have mw mass of the water, and initially mw of mass of the water will be there, and then here the mass of the gas, it is still whole amount of the container with the mass of the water, not with the gas, no single particles of vapor present here, therefore it is equal to 0. Therefore the drainage fraction as per the formula, it is 0 divided mass of the liquid plus 0, therefore it is the x value will become 0. Next, as for same volume of water, I will supply the some amount of the heat energy through the fire or something, geothermal energy, nuclear energy, whatever. I will supply the heat energy. When I supply the heat energy, that will be started to convert it into the vapor phase. What, from liquid phase to the vapor phase, it will be started to convert it. Therefore there is some amount of the vapor, some amount of the water will be there. Therefore your x value, that's drainage fraction, will be vary from 0.11 to 0.99. that is of course it will be varies from 0 to 1 here. If it is fully liquid, then it will be 0. If it is fully vapor, then it will be the 1. X value will becomes 1. Therefore, see, after supplying continuously heat energy to the same volume of the water, then the whole amount of the water liquid phase will be converted into the gaseous phase. Therefore, you see here mg divided by mg plus 0. What is the 0? This is the 0 for liquid water. Liquid water mass is 0 here. Therefore, the drainage fraction here, it is equal to 1. Next, I will explain the simple Rankine cycle work between the boiler pressure 15 bar and a condenser pressure 0.4 bar. Supply of the steam to the turbine is dry saturated. Determine the Rankine efficiency. This is the thing what you want to consider in the problem. So the data given are the boiler pressure and condenser pressure. You note on the boiler pressure and then condenser pressure. Therefore this is the schematic sketch of the simple Rankine cycle: turbine, condenser and boiler, pump. This is the schematic diagram. You know very well that. So this is the first, the second law of thermodynamics can be explained by using this one. See, this is the turbine. Getting my point? This is the turbine. Therefore this one will be considered as the heat engine. In according to second law of thermodynamics, what is this? What it will say? Whole amount of the heat energy that you are supplied to the engine can't be converted into the work. Some amount will be go to the sink. Here that sink will be the condenser. Therefore the later we can discuss. See, this is how your steam turbine, single stage steam turbine will works. High pressure, high temperature steam will be supplied to the turbine, and then it will be comes out of the turbine as liquid plus vapor phase. See, dry saturated or superheated steam will be enters to the turbine, and then it will be comes out as the liquid plus vapor phase. Here it will be the both the phase, it will be there, liquid plus vapor. And then when it is comes out of the condenser, it will be fully condensed into the liquid phase. What is the condensation process? Condensation is the process of conversion of liquid plus vapor phase or vapor to the fully liquid phase. That is what we so called as the condensation process. That is happens at the saturation temperature and constant. Then liquid will be pumped to the boiler. It will be pumped to the boiler. Again it will be the liquid only. Dry saturated steam enters the turbine, expanded in the turbine, it will be converted into the liquid plus vapor. This is so called as the wet steam, and then in the condenser it will be turned into the liquid phase. Liquid will be pumped to the boiler. In your home also you will have some pump in the low head to the high head. Definitely the phase will be the same. See, liquid plus liquid only. Therefore this is how your turbine works. Next, let us go for the problem. What is the problem given? In that problem, that initial pressure it is given, that is the boiler pressure 15 bar. Next, condenser pressure it is given 0.4 bar, and it is given 0.4 bar, and then this one will be it is pumped to the 15 bar. Dear students, while watching this video, please note down all the sketch in the notebook, and then you have to note down the pH diagram also, otherwise you can't understand what I am please note down with the notebook, otherwise it is very difficult to understand the subject. See, this is the steam table. I am practicing that thermodynamic data handbook. From that I have scanned the copy. What is the condenser pressure? It is given 0.4 bar. See here, 0.4 bar condenser pressure. Where it is there? 0.4 bar, and then you note on all the values like specific volume of water. This is liquid phase, this is gaseous phase. Okay, specific volume, sensible heat, latent heat, and then total enthalpy, and then similarly sensible entropy, latent entropy, and total entropy. You note on all these values. And similarly at 15 bar pressure, see here have this 15 bar pressure, you note on all these values, and then the values while you are not down, it will be like this. This is the value you are going to note down. So you are getting my point at 15 and 0.4 bar. You are getting all these values. After getting this, you please prepare the steam table. 15 bar and 0.4 bar. All these values you please pause the video and then note down all the values. Importantly, you want to note on the specific volume of the liquid at condenser pressure. See here what you have the condenser pressure. At this point you have to note on the condenser pressure. At condenser pressure specific volume. See here condenser pressure. At condenser pressure you want to note down these values. So these are the things you want to practice. Let me explain today about the Mollier chart. That problem can be solved by two methods. One is so called calculation method by using the steam table. Another one you can solve directly by using what? Your Mollier chart. Don't start with the Mollier chart. This will be helps you to solve the problem for reheat cycle. Don't go for this one. Just let me explain this one. How it will be there? See here. See, this is the Mollier chart. It is given. In the y-axis you can find the enthalpy, in the x-axis you can find the entropy, and then the lines you are seeing in this direction, these are the constant temperature lines, like 400 450 degrees, like this it will be there. And then here you have the inclined lines, somewhat inclined lines. These were the blue lines, so called as the pressure lines, constant pressure lines. These are so called as the constant pressure lines. Any doubt you can please note down the properly this one Mollier chart. And then the line here you are seeing, right, this line you are seeing now, this line is so called as the dry saturated line. See, the dry saturation means here fully it will be converted into the vapor phase. That's why your x value is equal to 1. Otherwise it would be comes to the liquid plus vapor or superheated phase. This is liquid plus vapor phase. This one, this is the superheated phase. And then in this you can, if you have two coordinates like entropy and then pressure or pressure temperature or dry saturated and temperature. You can find any values at that particular point, like your dryness fraction, your pressure, temperature, enthalpy, entropy, everything you can find out. Okay, let me explain next. This is the thing how it will comes. So superheated will be superheated lines will be like this, saturation temperature lines will be like this. This is superheated point, this is liquid plus vapor point, this is dry saturated line. Okay, next this is the same. See, in given problem that the fluid is transferring from dry saturated point to the liquid phase, that is it is expanding on the turbine. It is expanding on the turbine from 15 bar to the 0.4 bar, then its enthalpy will change. See, here it is having dry saturated, it will be liquid plus vapor phase, therefore the pH diagram will be like this. This is the pH diagram. Then at 15 bar you have H1 is equal to Hg, that is equal to 2789.9 kilojoules per kg. At why it is so? Because since the entry to the turbine is dry saturated, therefore the enthalpy H1 is equal to this much. Steam expanded on the turbine and it reaches the wet steam. What is the wet steam? It is a mixture of liquid plus vapor phase. Therefore wet steam means it is the mixture of liquid plus vapor phase. Therefore your enthalpy will be is equal to HF plus XHFG at condenser pressure. What is HF? It is sensible heat. This is latent heat. It is decided by the what X value. If the X value is equal to 1, then you see if X value is equal to 1, HF plus HFG. If X is equal to 0, H2 is equal to HF, like that it will be there. See, you put all the values, you know, at condenser pressure you put HF and HFG from the table, this will comes, but you don't know the value of what? X. Therefore you want to find the value of X by using the isentropic expansion concept, where your entropy S1 is equal to S2. Your entropy S1 is equal to S2. See here. See, entropy S1 is equal to S2. Therefore, you want to take S1 is equal to S2. But entropy at S1 is equal to Sg, since it is dry saturated, but S2 is equal to Sf plus XSFG at condenser pressure. At what? Condenser pressure. Therefore, this is S1 is equal to Sg at boiler pressure, S2 is equal to Xf plus XHFG at condenser pressure, and you have these values. Sg you put this one and then equate with this one. You have all these values in your steam tables, and then X value will be is equal to 0.83. X value will be is equal to 0.83. Therefore, H2 is equal to 317. This one you put H plus 0.83 into 2319. H2 value you got. Now fluid enters the condenser from state 2 to the state 3. That is, fluid enters to the condenser. While it is entered to the condenser, it is condensed into the liquid phase. That means here fully it will be converted into the liquid phase. You see, if in this formula only, if you put X value is equal to 0, if it is becomes 0, it will be remain with the 31.7. Therefore, this is the thing what happens in the pH diagram. 2 to 3, see, 2 to 3 it is condensing. Therefore, your wet steam fully converted into the liquid phase. Therefore, H3 value is equal to HF. Already I told you, if you put X value here is equal to 0, then it will become 317 kilojoules per kg. Next, you have to go for the pump work. The pump work, how it will be there? See, you have boiler pressure, condenser pressure, enthalpy here H3 and then enthalpy it will be H4. Therefore pump work is equal to H4 minus H3. Therefore H3 you know, H3 value you know 317.7 kilojoules per kg, and then you have to go for the pH diagram 3 to 2 to 3 to 2 and then 3 to 4 it is compressing, that is pumping from 3 to 4. See 3 to 4 you have to go. Therefore pump work it is equal to VF of PB minus PC of kilojoules per kg. Therefore VF value already I told you while explaining the steam table, your value is 0.0010265. Therefore you put this values, put this values 15 bar 15 bar, put in terms of 10 to the power of 5 Newton per meter square and then meter cube per kg. This will be converted into the kilojoules per kg. Therefore it will be like 1.498 kilojoules per kg. It is equal to H4 minus H3. You know the value of H3, you know value of H3, put in this equation, you will get the value of H4. This is the value of H4. You have all the values now, H1, H2, H3 and H4. If you want you can in your drawing, in your notebook you can note on all the values H1, H2, H3, H4. Now the amount of heat energy given to the fluid in the boiler, that is equal to H4 minus H1. Heat is supplying here, you see here I am showing the direction here, heat is supplying, that is H1 minus H4, amount of heat energy. Then turbine work, you know this is the turbine H1 to H1, it is expanded. Turbine work it is equal to H1 minus H2, put all the values, you will get this one. And then condenser, amount of heat energy rejected in the condenser, that is QR, it is equal to H2 minus H3. This one you will get this value. Boiler, amount of heat energy given to the fluid in the boiler, that is to the water in the boiler, H1 minus H4, you will get this value. Then network, what do you mean by the network? Some amount of the work produced by your turbine will be absorbed by the compressor. Therefore network is turbine work minus pump work. This is the turbine minus pump work you got. Therefore your Rankine efficiency, what is the efficiency? It is input to the output to the input, sorry not input, it is output to the input. Therefore your Rankine efficiency can be explained by second law of thermodynamics class statement, that amount of heat energy supplied and amount of, by considering amount of work produced, that network is produced WP, that is it is to be WTA. Okay, anyhow this is what? Turbine. Okay, next you have network like this, WN, it is supposed to be, sorry this is given WP, it is not WP, WN, W network divided by heat supply. This one will gives the energy, this one will gives the power, that is required power, this is the power, and in terms of kilojoules per kg, amount of heat energy supplied, that is 33.92%, that is Rankine efficiency you will get. Thank you one and all.